Hello ladies, gents, and everyones. It is Thursday, February 4th, and we're here to talk about this week's space and astronomy news. So we've been teasing it for weeks, but Starship SN9 finally actually happened. So we were hoping for it to be last Thursday, but it was delayed again, and this time not by weather, but by the FAA, because it turns out that SpaceX was denied permission for the SN8 launch back in December, and they launched anyway. Naughty Elon. So the FAA wasn't happy about it, and so they were doing an investigation to make sure that SpaceX wasn't going to be pulling any shenanigans or endangering anyone with the SN9 launch. But they finally signed off on it, and the SN9 test happened on Tuesday. Similar to the SN8 launch, the SN9 was powered up to its apogee of about 10 kilometers by 3 Raptor engines, which cut off in turn. Then they did the belly flop maneuver and came down for a controlled re-entry, which was controlled using the flaps on board the Starship, which are each controlled independently. And then the Starship went to realign for landing, and at this point, unfortunately, one of the Raptor engines didn't relight, and so the ship was going way too fast and it crashed again. This might look familiar if you saw the SN8 launch. So again, SpaceX got a lot of great information for this, but at some point we do want to see this land without a fireball, although fireballs are pretty cool. And the SN10 Starship is already on the launch pad, so hopefully that test will be coming up pretty soon. So NASA's Space Launch System had their final green run test of the core stage in January, and we discussed it and we said that it wasn't a fully successful test because they intended to hot fire all the engines for about 8 minutes, and they only did it for about a minute. So NASA and the lead core stage contractor, Boeing, have been looking into whether or not they need to redo this green run test. And they decided that, in fact, doing this second test will be beneficial. It will propose minimal risk to the Artemis 1 mission while giving them a lot more information that will be helpful for the core stage, not only for Artemis 1, but for future missions that are planning to use this SLS core stage. NASA is targeting the week of February 21st to conduct this second green run test, and in the meantime they're prepping for the test by continuing to analyze the data from the first test, drying and refurbishing the engines, making minor repairs to the thermal protection system, and they're also making adjustments to the control system that caused the automatic shutdown during the last test with a very conservative safety setting. After the second hot fire test is completed, assuming it's successful, the core stage is going to be transported to Kennedy Space Center, where it will be assembled with the rest of the SLS and the Orion spacecraft in order to launch Artemis 1, hopefully later this year. So last week we talked about the first all-commercial crew mission to the ISS in 2022, but SpaceX just announced a new all-private space crew mission to orbit this year, which will be the first all-commercial crew spaceflight to orbit. Inspiration 4 is planned to launch in the 4th quarter of 2021. It's going to use a Dragon capsule, and it will be a multi-day mission in orbit around the Earth. There are going to be 4 seats on this mission. One of them has already been filled by the leader of the crew, which is going to be the CEO of Shift, but 2 more seats are actually up for grabs, and one of them could be yours. These seats are called the Generosity and the Prosperity seats, and you can enter the sweepstakes to win by either making a donation to St. Jude or by starting a shop with the Shift for Shop. The crew selection is going to be in March, so if you're interested, go ahead and check this out and get your name in soon. Astronauts on board the ISS had their second spacewalk of 2021. It was the same that did it last week, Victor Glover and Mike Hopkins. They went out to replace the batteries that store energy from the solar arrays, as well as upgrade some of the external cameras. This actually marked the completion of a 4-year project to replace all 48 aging nickel-hydrogen batteries with 24 new lithium-ion batteries. The work was completed faster than expected, so the astronauts were only outside for about 5.5 hours. Lastly, scientists at Fermilab are hoping to announce as soon as March a new measurement of the magnetism of a particle called the muon. Ever since 2001, there have been some measurements hinting that the muon is actually more magnetic than theorists expected. And this excess could imply the existence of new, previously unknown particles. Currently, the gap between the measured and predicted magnetism of the muon is about 3.7 times the uncertainty, whereas particle physicists usually take about 5 times the uncertainty to be the threshold for considering something a discovery. So this new, more precise measurement by Fermilab could kind of narrow down whether or not this is a real significant effect. And to ensure that the researchers aren't unconsciously biasing their results, they do something that's called blinding. And they're doing some pretty extreme blinding for this experiment, which is called muon G-2. When they're taking their data, they actually don't even know what the frequencies are. They use a randomly generated frequency that's totally unknown except for 2 people, and it's like locked in a sealed envelope inside a locked cap. Like, it's crazy the extent to which these scientists are going to. And then eventually, at the end of the experiment, they get to unblind the results, and it's a really exciting moment for the scientists because they don't know. They've been working on this project for years, and they don't know what their results are yet. So it's pretty cool. I'll link the article below so you can check it out. And now you might think particle physics is kind of the opposite end of the physics spectrum from astrophysics, where we're talking about things like galaxies and superclusters and everything. But they're actually more related than you might think. So a lot of the physics that produce the spectra that we see in astronomy, the electromagnetic spectra from objects, is driven by the physics of the particles. And so we need to understand the particles in order to have a full understanding of what we're actually seeing. There's also, for example, something called cosmic rays, which are these very fast-moving charged particles, and they interact with the Earth's atmosphere. So we don't usually detect them directly from the ground, but when they hit the atmosphere, they create what's called a particle shower. So basically they create a bunch of particles in the Earth's atmosphere that shower down to the surface, and we can detect these showers, but we need to understand the particles that are resulting from these interactions in order to actually be able to understand the cosmic rays that initially started it. So yeah, particle physics is actually super important for astrophysics. There's a whole subfield called astroparticle physics. So anyway, I think this is a pretty cool result. I can't wait to see what Fermilab announces for this mu1 G-2. So there you have it. That's a little bit of what's been going on this week in space and astronomy. I hope you enjoyed, and I'll see you again next week. Bye.